I'm going to discuss some mechanics questions with you just to support you for the exam that's coming very near, right? So your exam will be there in about 2 months, so I will help you out with some questions. So let's start with 2013 question number 50. In that you can see there is a path like this, and there is a mass m, object B, so it is like this, and the height is h, and then finally it goes like this. The mass of this is capital 2m, and this is object A. So they say when object B leaves object A, what is the velocity of A? Now thinking practically, what can you understand? Thinking practically, you can understand when this object leaves, this object goes back. Now looking at the system, initially at t equals 0, you can look at the system at t equals 0. What's the meaning of this? Here, before releasing it, the initial momentum of the system is 0. Because between object A and object B, what occurs is what? Internal forces. So when you consider the system as a whole unit, you can say that those internal forces cancel off. Now, there is no other external influence on this system. What's the system? Object A and object B. Then the sum of linear momenta of object A and object B should be equal to constant. But here we know the initial momentum is 0 because both objects are at rest initially. As there are no external forces on the system, we can say initial momentum is equal to what? The final momentum. Therefore, the final momentum should also be what? 0. I hope you understood that. Now, physics is a subject where you have to do questions logically. Try to understand the theories really well. Sometimes it may take a long time to understand a particular question. It's okay. Try a question really well, with real theories, with a great theoretical understanding. Not just memorizing because the question is done like that. Like most students memorize because there's a question, this is how it's done. And therefore looking at that question type, we are going to solve another question. But you can't do that. If you do that, you can only answer particular varieties of papers only. Sometimes they change the physics paper. It may get tough. So we have to get adapted to those conditions where they make papers different. Alright, so then we have the initial momentum to be 0 and the final momentum of the system to be 0. That we understood. Now how can we solve this question? They say there is no friction in this surface, and here also there is no friction. All these surfaces are no friction, do not have friction. That means between this surface and this surface there are no frictional forces occurring. And here also between this object and also this surface there is no friction occurring. So everything is smooth. Now we can say, then, now look at this. When you think about energy, we've got to solve this using energy and momentum. When you think about energy, initially we have an energy. This object, B, has a potential energy. That potential energy is going to get converted into what? Kinetic energy. Kinetic energy of this ball, this object B, and kinetic energy of this object A. The potential energy of the object B is going to get converted into the kinetic energy of this object A and the kinetic energy of the object B. Now somebody may be having this question, what about the potential energy of A? The center of gravity is here. No problems, because after B releases, A goes back like this. But the position of the center of mass of A has not changed. Therefore, the potential energy of A has not changed. Therefore, no point of talking about the potential energy of A in terms of what? Energy conversions. Now, when we talk about energy conversions, you should see what happens to the potential energy. If the energy is not changing, no point of talking about the energy. I hope you understood that. Right, then, what we can say is this. We can say what? What's the potential energy here? mgh. This potential energy mgh is released as kinetic energy of object B and object A. What is the kinetic energy of object B? The velocity of object B, we call it v dash. Velocity of object A, they have mentioned, that is v. Therefore, half the mass of B, m, velocity of B, v squared dash, plus the kinetic energy of A, that is what? Half 2m v squared. Then we can say capital M cancels off. Here we have what? GH should be equal to, now 2 is common down, so we have what? V dash squared plus what? 2v squared divided by 2. Now we should get a relationship between what? V dash and V, because we are going to find V. How can you get a relationship? I said initial momentum is 0. Final momentum of the system is also what? 0. Then, for the final momentum to be 0, the sum of this momentum of B and this momentum of A should be equal to 0. That means capital M V dash in this direction plus 2m V in that direction should be equal to 0. But I'm considering this direction. When I consider this direction, I can change this as what? mv dash minus, now, because I'm changing the sign, 2mv, this direction. Should be my vectors. That should be equal to 0. Then I can say mv dash should be equal to 2mv, m cancels, so v dash is equal to what? 2 times v. I can substitute it here. GH is equal to, now what is V dash? 2V squared. Do it mentally. What is 2V squared? 4V squared. 4V squared. Plus 2V squared. 6V squared divided by 2. 6V squared divided by 2 is what? 3V squared. Therefore, GH should be equal to what? 3V squared. Therefore, V is equal to what? GH divided by 3 square root of that. I hope you understood this. But we can solve this question using a different variety of solving this. What's the other method? Can we calculate this? Kinetic energy E is equal to half mv squared. I'm going to multiply m and divide by m. Multiply by m and divide by m. Do I do any harm? No, because m divided by m is 1. What I get here is half m squared v squared divided by m is equal to E. E is equal to what? M squared v squared means what? P squared divided by what? 2m. So E is equal to what? P squared divided by 2m. This is very important. I can write kinetic energy as momentum squared divided by 2m. You know, the momentum of A in this direction, P, momentum of B in this direction, after B is released and A goes back should be equal in terms of magnitude but opposite in terms of direction. Why should their momentums be equal in terms of magnitude but opposite in terms of direction? That is because the sum of their momenta, linear momenta, should be equal to 0. That means this direction momentum should be equal to that direction momentum, such that the momentum of the system should be equal to 0. Now I can write kinetic energies of A and B in terms of what? The momentums. Let's do it. So, what can we say? What's the kinetic energy of A? Is equal to what? Momentum of A, that is equal to P. Should be P. So P squared divided by what? 2 times, what's the mass? 2m. It's kinetic energy of A. Kinetic energy of B, P squared divided by what? 2 times m. Now what can we say? These two kinetic energies are resulted due to the conversion of potential energy of P. Therefore, mgh should be equal to P squared upon 4m plus P squared upon 2m. I can multiply by 2 here and 2 here. Then I get common denominator 4m. Therefore, I get 3p squared divided by 4m is equal to mgh. So I get m squared times 4 times gh is equal to 3p squared. Right. I may erase this part. So I get m squared 4m squared gh divided by 3 is equal to p squared. What is p squared? I'm going to find whose velocity? I'm going to find the velocity of A. Therefore, I better write the momentum in terms of the velocity of A. What's the momentum of A? 2mv. Momentum is m times v. Therefore, what's the momentum of A? The momentum of A is what? Now 4m squared gh divided by 3 should be equal to the momentum of A squared. That means 2m times v entire thing squared. What do I get here? 4m squared gh divided by 3 should be equal to what? 4m squared v squared. 4m squared cancels off. I get gh divided by 3, the square root of that is equal to v. I hope you understood this. So we'll solve further questions after this video.